Today, I'm again very grateful that you've joined today to listen in about the topic of data quality. We call the presentation "Action versus Procrastination" because data quality for sure is not the most sexy topic to talk about. There might be more interesting and more appealing topics, but uh, still, data quality is one of the most important topics that you need to address, especially when you want to do some data analytics. I'm Richard from IFOC. I've been in the wind industry for quite some time. I'm sure that many of you might already know me. And today I will talk about data quality aspects, about the concept of critical data path, about IFOC recommendations towards data quality and how to do it. And last but not least, I also want to mention a tool that we use at IFOC called IFOC Data Check that helps us to address the topic of data quality issues. Um, what is the critical data path? And since data quality is a quite dry topic, I tried to also add some fun parts. I found a Dilbert cartoon talking about data quality. Um, of course, talking about data quality, as I mentioned before, is a dry topic, but you should still take it seriously, and you don't should not think of it as being some magic that can be just yeah just done by someone in your organization. You really need to address it in the right way and take it seriously. Um, so, what is the critical data path, and what is the concept of a critical data path? For me, and especially in my professional career, I looked at data quality as being a multidimensional problem. Um, in every aspect, when you look at data quality, it will have some different things that you need to consider. So demands for data quality will vary based on the questions you ask yourself. This reminds me of the topic of logbook analysis from wind turbines, where also the questions that you are asking will influence the way how you need to look at the logbook data, and the same is true for data quality. There will not be a one size fits all solution towards data quality. You need to look at it as a multidimensional problem, and you need to solve it as one. And always keep pragmatic. So pragmatism is needed. You only need to solve the data quality problems that you're really facing. And just before we had an internal discussion about the whole topic of data quality and how to address it. And I needed to remind the team of this approach and say we only need to solve the real problem at hand and not everything, because then we expand the problem to a much bigger scale, and we block all activities inside the organization for to solve things that might not really add value to the business case at the end. Yeah, and in order to understand what is your critical data path, you also have to understand what are the KPIs that you want to produce, what is the things that you need to report about. Um, and to understand the need of a report and the need of this kind of process, you need to integrate all stakeholders into the discussion. You need to understand how data is generated at the source, how it is stored somewhere, and then how you need to transform it, and what you need to report, and what is actually the content of the report, and what do you want with this report. And only if you have understood this as an end-to-end process, you will be able to or take the right measures to ensure data quality. And you have to define your own KPIs carefully based on the real data streams. What does this mean? Um, if you just have a KPI that is very vague in its definition, you cannot make sure that the quality of this KPI is always high, the data quality of this KPI. So you need to think, what are the KPIs that really help you to increase your business intelligence, and then you need to make sure that you can calculate these KPIs based on the real data streams, on the data sources you're having, and then you're on the right track, because you have defined a very, very important aspect of your critical data path. Um, and another thing that is very important to me, whenever you have daily processes, please try to integrate also data monitoring, data quality aspects into these daily processes. Um, because once you did that, and once you see this as being on the critical path for the for the KPIs that are really needed on your day-to-day basis, you can always also change things very close to detecting them, and that's always the key to keep things as efficient as possible. So yeah, it's the critical database part is obviously about completeness of data, uniqueness of data, timeliness, so that validity, accuracy, and consistency. So this is like everything contributing, but all on a different level based on the use case that you have at hand. So um, stay pragmatic and don't try to solve an accuracy problem that actually starts in the data source, and things like that. So I also have an example of a critical data path so that I can give a little bit more flavor to this. Um, the reporting of production data. This sounds so simple and should be so straightforward, but as a matter of fact, it's not, because in many systems you are not aware of how is the production KPI really calculated, which is the source data coming from the wind farm. Is it different from one manufacturer to the other? And I think to there the definition of the critical database starts. So you need to understand first: do I want to report scalar data, or do I want to present metadata that I get actually from the grid operator? Do I use the active power signal and calculate the production based on the active power average, or do I use cumulative production counters that I get reported from the data sources? Um, it's sometimes there might be a mixture, because some of the OEMs do not offer you cumulative counters, others do. So you need to know which is which, and then you can understand how to monitor your data quality. Um, Different OEMs offer different data sources. This is what I just mentioned. And then, yeah, you need to understand what are your quality aspects that you have to monitor. If it is, for example, the cumulative value, and your KPI formula is day end minus day start equals production of each day, you might end up in a scenario like I have sketched in this diagram. And when you want to correct a counter jump that might have appeared somewhere during a day, because some service technician did something on the turbine and entered the wrong offset, or the turbine did some wrong readings, you might end up in a daily production counter which tells you, I have X kilowatt hours at the day start, and epsilon kilowatt hours at the day end. And then you make the difference, and then you understand this is an impossible production that I have. I produce more than full load hours possible of the turbine, or you have some other quality KPI based on the average wind speed and estimation what could be the maximum production for the day. And then you get a flag, and then you look at the data and you see, oh, I have a meter jump, cumulative meter jump on the day. And then you don't have to correct every single 10 minutes timestamp for this signal. You only have to look at this particularly one of those on those occurrences, and you need to correct that permanently. because you know your formula works day end minus day start. And you don't need to bother about correcting all the other timestamps because you're not using them in your day to day workflow. And they will not influence your data quality negatively, especially for this particular use case. So um, this is very important to know, because when this offset error happens somewhere during the day, you can actually ignore it because it's not worth spending the effort. And this is what I meant by knowing your KPIs, knowing your critical database path, and not investing time where it's not needed. Another example that I want to give you is about correct data labeling. And this is especially important when we are talking about collecting data from different sources, from different turbine manufacturers, and send them into a bigger data lake, a second level SCADA system that might be, and then you have different source name, and you want to make sure that at the end in your second level SCADA system they follow a one naming convention and expose them to others. And I have an example of turbine type A where you see the main box bearing temp not main bearing temperature, that's the right word, is called gear underscore main bearing, or main bear underscore temp RE average. And then you have your signal labeling to your second level SCADA. It's called um, however it's called main bearing temperature front or rear. And then when you want to expose it to some other services, like for example I4C, there might be a new naming convention added on top, and you see that this is a big error prone process, because here might be an error directly made by the original SCADA source. Then the second level provider can make an error, and then obviously also everyone else connecting to the data would have the same error based on the second level SCADA system or the first level SCADA system. And in worst case also here errors might happen. And it's not that easy, because in a second scenario you might not even have a gearbox, so a complete set of data is missing. But still you want to make sure that these names of raw signals are somehow um, okay in your second level system, in your data lake, and then can be used by third party systems. And you need to have a consistency check, and that's very important. So this can be a one-time project, or from time to time screening, where you just make sure that data labeling is correct, and that you have accurate and precise data in your second level system. That's a really important thing. And I know that a lot of systems are struggling with that, because this is often a manual process that takes quite some time, um, and it should get the right attention. This is also something that I want to encourage you. Go into these details, make sure that you understand the whole journey of a bit and byte in your system, from the source to the destination, and make sure that all the labels are correct. Do this because it will tremendously influence your data quality positively. Um, so our recommendations, it's really stay pragmatic, solve the problems at hand in always the easiest way. Once you have done that, and you're facing another problem, then address it, and do it incrementally, do it step by step. Um, Really go into the struggle of understanding your most important KPIs. I know that a lot of software platforms calculate many of them, and you will not have time to understand each and every of them, but define the most important ones and really go into the details. It will help you understand the source data better. It will help you to understand everything along this critical data path in a better way. And at the end, the performance of your fleet will be improved by purely understanding the data. You will save time in your follow-up processes because you know what you're talking about, and you have made sure at one time that everything that also your OEM provider, operations and maintenance provider, understands what you're talking about. And handle data quality issues pragmatically, only fix the problems that really add value to your business case. And this is coming back to the example with the cumulative data. If you only need time stamp for day start and day end, only fix those and make sure that they are making sense, and use manual where it's really important and you can really influence it, semi-automatic or fully automated tools, and do whatever helps you the most, and just don't fall into the trap of saying everything needs to be automatic, because at the end we all just want to get on with business and want to solve a thing and go on to the next, and don't get stuck in very complex problems that might not add value to our business case. So now I want to give you another use case of how we did it at I4C, because we also have the challenge that we connect to a lot of systems out there, a lot of data points, a lot of different turbine types, and we needed to solve this data quality issue for ourselves. And we invented the app called I4C Data Check. And I4C Data Check is like our data quality firewall. Before anything can go into an analytics process, we make sure that the data is what it appears to be, that the data quality is good enough to actually do some data analytics, and that you, at the end, do not fall into the trap of thinking, I've spotted something, but at the end, you only found a data quality issue, or you were checking the data quality on, or the temperature of a generator bearing, and you thought it was a main bearing. These kind of things. This should not happen. I foresee a data check is helping us to provide this. So we detect missing signals, incorrect signal mapping, which addresses the second use case that I talked about. So end-to-end data labeling can be checked by using I4C Data Check. We understand if there are some holes in the data, low data completeness, if the data is not behaving as it should. For example, an ambient temperature should be in a range of certain values, and it should have a difference between day and night and things like that. This can be all automated and checked on a regular basis. And then we decide this can be used for data analytics or not, and if it can't be used, we have fallback rules going to weather data from external services or things like that. So it's all built into our own processes, because we want to solve a problem. We want to provide high quality data analytics, and in order to be able to do that, we need to address the data quality issues before. And the concept is usable also for other things. So why? Yeah, I think to sum up a little bit, what I want to talk, or why we were addressing this whole topic. It was basically the last slide that I was talking about. I4C needed to solve the data quality issues on ourselves. So to be able to provide high quality data analytics, and of course, these results that we have with I4C Data Check also help the industry to figure out what are the mapping issues that we are having. Are there some data quality issues that we should address on the site in order to solve them once and for all, so that we don't have these problems in the future. For me, again, a very important thing is this critical data path. Um, to follow the critical data path, to know this concept, to have this concept in the back of your minds whenever you address some reporting or data analytics issues. And I hope that I could like showcase what I mean by critical data path, or what I4C sees as critical data path. Um, I showed a little bit the capabilities of I4C data check. Obviously, data check can also be used to monitor the data that is most important for your KPIs. So, for example, these cumulative values, we can check if the day end and day start timestamp are here, if there are some implausible jumps on the day, and these kind of things, and then they can be reported on a monthly basis back into your operations team, so that you can fix these issues and you don't have any ongoing reporting problems in your organization. And yeah, and last but not least, um, you can check out our blog page for more infos. The content about data quality will be added soon our to our site. And that's about it. I promise to make it quick and condensed, because yeah, data quality is important, but sometimes not so much fun as talking about upgrades and talking about performance analytics. But still, it is very important. And so, thank you for listening in. And I'm here to answer any questions for the next couple of minutes. And